Hello there and welcome to question 3 from revision sheet 1. Let's get started. So we have two complex numbers, z1 which is the square root of 3 minus I, and z2 which is in argument modulus form, it's 8 cos 3 pi by 4 plus I sine 3 pi by 4. So let's look at question A. So it asks for us to write z1 in argument modulus form, just like z2 is. So let's get started. So we have first got to find the argument and then the modulus, and then we'll write it in argument modulus form. Let's start with the modulus. It's ever so slightly easier in my opinion. So let's plot this complex number on an Argand diagram first, and the modulus is going to be the distance from the origin to that complex number. So going along the real axis to the square root of 3, and then down to minus 1 on the imaginary axis. So I'm looking for this distance here. And just as you found the distance between two coordinates when you did Pythagoras' theorem, we're going to use Pythagoras' theorem here again to work out this modulus. It's got a square root of 3 on the top, and it's got a 1 down the side. So the modulus of z1 is going to equal square root of the square root of 3 squared plus 1 squared. And I'll do this very quickly. Square root of 3 squared is just 3, add on to 1 is 4, square root of 4 is 2. So the modulus of z1 is 2. The next thing I need to do is the argument of this complex number, and that is the angle starting from the real positive axis, either going round anti-clockwise to that complex number, or in this case here, going round clockwise to the complex number if it's on the bottom. So I'm looking for this angle here, this theta angle here, and my answer is going to be negative as well because it's on the bottom half. Now what I'll do here, I've got a right angle triangle still, and I will just use a tan angle to help me work out theta. So it's going to be tan minus 1 of, and it's opposite over adjacent, so 1 over the square root of 3. Which is pi by 6. But that's not the answer to the argument. Remember that our complex number was on the bottom half of the Argand diagram, so the argument is in fact minus pi by 6. So combining these in argument modulus form, and argument modulus form always looks like r cos theta plus I sine theta. And all you need to do is just substitute in your r value, which in this case is 2, and the theta value, which is minus pi by 6. So z1 is equal to 2 bracket cos minus pi by 6 add I sine of minus pi by 6. Excellent, so that's part A done, 2 marks for that. Part B, compute z1, z2, all modulus. Now what I can do here is I can use the theorem that z1 times z2 and find the modulus of it can be calculated by multiplying the two separate moduluses just like this. And my argument modulus form is really helpful to work this out. z1 modulus, we worked that out as 2, and I need to times that by the modulus of z2, which we can see in our complex number at the top here, that's 8. So 2 times 8 is 16. And that's all we need to do for part B. Part C is to work out z1 over z2 in argument modulus form. So let's do this. z2 divided by z1. Now the rule for the arguments and modulus here is we continue to divide the moduluses, and then when it comes to the arguments we do a subtraction of argument for z2 take away argument for z1. So that's going to be 3 pi by 4 take away minus pi by 6. And exactly the same thing for the sine as well. 3 pi by 4, take away minus pi by 6. So all that's left to do now is just work out these subtractions and this division. 8 divided by 2 is 4 times by cos of 3 pi by 4 add pi by 6, as we have the double negative there, and for that we get 11 pi by 12 add I sine 11 pi by 12. And that's all we need to do for part C. 3 marks for that, 6 marks in total.